Lekazir anober mai Lekazir anober mai Lekazir anober mai kan triat ngai lo le zir ngai lo te po kan hu lo le kan cho ngai lo te po izir zelang maso turin izir zelang maso turin Lekazir anober mai Lekazir anober mai Lekazir anober mai. Hello guys, today we shall start Unit 4, that is Electromagnetic Induction and Alternating Current. So Chapter 1, we shall start Chapter 1, that is Electromagnetic Induction. Okay, so I shall talk about the introductory part like Oersted experiment, Faraday's experiment, and how he discovered and induced current, and about induced e.m.f. also. Okay, for today. So first of all, if you look yourself around, then you will see in your house like doorbell. I think you have doorbell. Inina in nei karinga. Trin ka chun nei lo mai thei boka. And voltage stabilizer, tube light, chalk. In some tube light there is chalk. And transformer inside TV or fridge. Fridge chunga te kan transformer te om trin ni. Mo ari vung vung trin a chang chuan. And also electric fan dynamo, or sometimes we call them electric motor inside fan, ceiling fan or table fan also, and generator tapo alien, a small one and a big one. Tiang ka om trina kan ne tun line la re mema, and also inductors and many more also. You must know that all these things, electronic gadgets, based upon electromagnetic induction principles. Okay, heng zong zong hi electromagnetic induction principle manga siam ania chu wang chon poi mo em antel lo chon tun la ya khosak pu ya harani kan man ro engkim mai hian cutting principle ngai kan computer ani amo TV ni amo fridge ani amo cutting zong zong fan ani amo chu kan soyang khan doorbell te chenin manania poimo hle ti na ni chu ha kan thrianga ti chuanin electromagnetic induction hi eng ti ka tangin nge an lo mu chua tu mu chua nge ti ha kan soidoni who discovered this electromagnetic induction principles. Okay, but first what you have to know is Oersted experiment. Let me talk about Oersted experiment. Okay, so in 1820 the Danish scientist Oersted discovered the magnetic effect of electric current. He sang kazariat sumni khan Danish scientist Oersted khan experiment tia chu experiment chuan wire a hian current kaltirin magnetic field hi ain siam ve ngala ni current kal hian ti kha mu chuaka tun maina hrengai lo reng ani he Oersted an mu chu main. So Oersted found that when wire AB carrying current was held over a magnetic needle north-south, such that electric current passed from one end A of the wire to the end B, as shown in the figure. The north pole of the magnetic got deflected towards the west into the paper. Okay, so you can see the figure. Let me show you the figure. So there is figure number 1, la figure number 2, omani alemain huang hian. So Oersted put a wire above the compass, like in figure number 1 again. So the original position of the needle, compass needle, is the green line. Okay, green line. So when you put a conductor and when a current is passing, then the magnetic needle just got deflected without touching here karak hian you can see also some empty spaces, no one touched and no one deflected, but simply it is deflected. Ama khop mai tro ama in lo in deflect ringot ta ne chulo cheson ringot ta wire chunga da khan. So it is deflected towards into the paper. Okay, ki arrow mark ang khian paper lam zong nang mani lam opposite to yourself. It is deflected opposite to you. Okay, into the paper means into the picture. Okay, not outward. He alem mi ka chuak zong ne lo in a lut zong in. But again, he did an experiment in the figure number 2. When he put the wire below the compass, wire kan nuaya dahan and current is passing, it is deflected again, but however the deflection is opposite to the previous one. Amami ang nen kan italawin, so orange color ki new position chunitani outward to the from the paper or outward from the picture, we can say nang mani lam zongin towards yourself aron deflectani chu acheson ani chu chungle nuaya da khana cheson ta ani chu. So it indicated that magnetic lines of force below and above the needle are directed in the opposite directions. Okay, thus Oersted experiment led to the discovery that when electric current passes through a conductor, magnetic field is produced around it. Chu mu chu chu ni ta ni chu chu nge kan ti chuan wire a hen current kalin wire a khan magnetic field lo in siam veringot thina ni ti ani chu. So we can see three things when he continued to do an experiment. He found out three things. Number one is whenever a current is passing through a conductor, then a magnetic field is produced. Ika number one ania. Number two, if a strong current is passed through a conductor, then magnetic field produced around the conductor is also very strong ania. Current kalkha achak po le magnetic field po in siam chak vezel mai tika muchuaka. Chuan, and in such a case, in number 3, magnetic lines of force near the conductor are found to be circular. Tika muchuak boka. Magnetic lines of force kan tika magnetic field kha kami current dungzui ni lovin aqualin magnetic field chu lovin siamani ti chu coil chu nge kan ti chuan we can know by a right hand thumb rule. Okay, when you wrapped around a conductor, current carrying conductor, when you wrap around the conductor, then your thumb point towards the current kaldan kha current chu ngilin wire zo zong in kala chu ikut zung pui ko na lam khani ta se amaro chu I finger ikut zung trang ho kha magnetic field chu lo ni ta ni. So your finger represents around about I mean your finger represents about the magnetic fields. Okay, it is wrapped around, so like a coil or like in circular positions like that. So a coil in tikhan alom ta ni chu kha magnetic field lo in siam dana ni chu it is called a right hand thumb rule or Maxwell's corkscrew rule ante bokta ni chu kha yang khan ariat thei ta ni kha tikhan sankazariat somni 1820 ya khan Danish scientist khan magnetic field a omani current akal hian wire tikha wire current akal hian magnetic field lo in siam ani tikha amu chuak dai to ni chu. Okay, kha Oersted experiment chu ni ta ni tichuan anu kum som vela sankazariat som thum pakhat in 1831 mo Michael Faraday discovered the effect called electromagnetic induction, just converse to the magnetic effect of electric current. Oersted then is scientist and allow in magnetic effect amu chu letling chi khan Michael Faraday khana ngai to ve ni chu letling zong khana ngai to ve thunga current in magnetic field asiam chuan ingatinge magnetic field chuan current asiam led ve theilowang asiam theilowang ti kha Michael Faraday chuan ngai to tlat mai ni chu ti chuan experiment te tia he hialo mu chok ta ni chu. So when a coil made of copper wire is placed inside a magnetic field chua han copper wire da chuan magnetic flux is linked with the coil. Magnetic flux omje chu kan la soyang nakina we'll explain about magnetic flux in the next episode. Okay, so magnetic flux chu magnetic field in a siam ani ta coil a khan lo omani atiani So Faraday found that when the magnetic flux linked with the coil is changed, magnetic flux kan ti che chuan and electric current start flowing in the coil. Current alo in siam mai thin ani ti ni. Mo current lo in siam thin. Chu wang chuan dar zai ve hi mo. Dar zai ve hi, that is a copper wire coil antia. Chu dar zai ve chu when you put in a changing magnetic field chering or magnetic flux khat lo chering a khan ida chuan then a current is produced in a coil. A dar zai han current lo in siam top mai ni chu a main current kha lo in siam ani chu engmo generator ami amo current heta AC connect khera ngai lo ni chu power source atangin ama khan lo in siam ve top ani chu mak ve khop mai chu Michael Faraday khan amu chuak tlat mai ni chu mo kha Michael Faraday na mu chu dan khania a letling join Oersted experiment kha letling join ngai to ve a ti chuan magnetic flux chering a khan coil kha azuda emo coil kha ti khan ati cheni nikina hemi experiment hi atakin kanla tilangan donani a Faraday's experiment hi mo nin lo end donani episode danga kham ti chuan ati chet khan coil a khan current alo in siam ta ni chu current lo in siam chu induced current antia chun induced current om chuan a driving force anti electromagnetic force kha alo in siam ve boka chu a induced e.m.f antitani induced e.m.f la induced current chu karon soifia chun zomang ani chuan induced current chu nge kan ti chuan when the magnetic flux link with the coil is changed then an electric current is produced provided the coil is close to one. The current so produced is called induced current tinia wire kan connect khan coil kha ti chuan magnetic field la coil kan zuti magnetic flux chering a coil kan zuda khan emo a magnetic field chunga coil kan zuti chet ring jok thum khan khoi ve po thei ve a khati kan ti khan current lo in siam ta coil a khan chu current lo in siam chu induced current antini mo induced current kha flow thei ta ni chu in connect vector ti khan flow thei ta chu induced current mizo tong chun induced kan ti chu om ti to pakai chu ni chi alo na current wa pakai ni lo amaro chu induce alo in siam chop ta ni chu lo om tir ta hetia current I hydropower in siama turbine te avira kan in chunga AC current kan laluta emo battery DC hey torchlight battery te kan siama current in pechuk ang kha ani lo ani in siam dana hi a current hi chin ang vek. All the current are same whether it is induced current or it is direct current and alternating current, all are current. But the production is different. I in siam danaka ay nang lomania and also the frequency may be different. The amplitude may be different or the vibration we can say positive to negative as in alternating current. Unidirectional oma direct current kan te khatiang kachu current vector ni chu. Current theu ni amaro chu anin siam dante om dante in anglo ringot khania induced current po hi engdang ni lovin it is simply a current a flow of electron khania maya but it is produced by the induction. Okay, that is why it is called electromagnetic induction lo titani. It is produced by the induction method khan tani chu ka khalo involved tani chu induction method ka khati kan ti chet khan magnetic field che atang khan wire han current alo in siam ve top kha induction induce kan titani chu that is why it is called electromagnetic induction an titani chu mo this one in what is induced EMF nge lo ni veang when the magnetic flux link with the coil is changed EMF is set up across the two ends of the coil in case the coil is open. The EMF so produces coil induced EMF. Open kan ti na chanchu wire more in connect lawa khan potential difference khalo oma chu the driving force anti electron drive to electromotive force anti khane chu o mangai kami potential difference a more in anglo electromotive force mo driving force omlo chuan electron kha akal kual thailo ni mo electron flow theina chanchu kami driving force wang khania chu chople chilin automatically it is also generated along with the induced current. Both exist at the same time. Mo a role in a nomani chu induced current cannot exist solely if there is no induced EMF, and also induced EMF cannot exist solely without induced current. Induced current lovin induced EMF thailo, induced EMF lovin induced current thailo, an dun ve ni chu. And because of this induced EMF, a current can flow, which we called the induced current. Kan lo titani chu driving force. So EMF chu nge kan ti unit ka potential difference V kan ti trina volt kan tia. Chun induced current chu current mo ampere mo unit ka SI unit ka ampere ka ne maya. Chun induced EMF chu SI unit ka volt kan ti boktani chu asang ve ta ti chuan. So the change in magnetic flux linked with the coil may be caused by varying the strength of magnetic field. Thil pan hi thei chu i magnetic flux le coil lo in link dan kha thil chin hi thei, or the production of induced current lo in siam thei dan kha chin hi pakhata chuan. Number 1 is varying the strength of magnetic field. Magnetic field ka current kan pek tam chuan magnetic flux lo in siam tama chu achering ta ni chu achangin a lian achangin a te chering a chu ta chu current in siam thei. So induced current can be produced. Number 2 chuan by the relative motion between the source of magnetic flux and the coil ania ti chemi alo point magnetic flux kha if we don't increase or decrease the magnetic flux, if we don't change the magnetic flux also, however, if we change the relative motion amo kalaya wire amo magnet lo in siam theina tur thira mo kan vati chet khan coil kan ti chet zok khan magnetic flux ti chelovin coil ti che zok taila current lo in siam la thei thoni chinhi ni chu. Number 1 is magnetic flux kan ti chetin current in siam thei. Number 2 is coil kan ti chetin magnetic field chunga khan current in siam thei bokani chu. A khoi mo ve poka kan ti chet chuan current in siam thei tinani chu. All at the khan electromagnetic induction low mu chu adan chu kanan suita enge induced current like induced EMF poimo e.m.f na kin kan la soi fo tur kha kan suitil ta boka current in siam chop magnetic flux lo che awanga coil a current lo in siam chop kha induced current induced EMF kan ti chu ni ta ti chuan kha electromagnetic bulpui electromagnetic induction bulpui chu alo ni ta ni mo Michael Faraday mu chu poimo e.m.f khania kan la zir don chawa ti khan ngun takin kan lo ngai to zelanga adang te po en zel kan lo tum don ni kan lo ti zelang ti chuan enge electromagnetic induction chunita. So the definition is like this: thus electromagnetic induction is a phenomenon of production of electric current or EMF in a coil when the magnetic flux linked with the coil is changed. Dikhania electromagnetic induction chu coil bula magnetic flux kan ti che ta wanga coil la current emo EMF lo in siam kha electromagnetic induction khami alo in siam dan phenomenon mo thil thleng khamia process lai ta kha electromagnetic induction chu kan ti chu ni ta ne chu mo. Okay, in the next episode we'll learn about what is a magnetic flux. Magnetic flux ka topic le chuan magnetic flux somje kan zir le donani. Okay, that's all for today. I hope you understand well.